Alright, we're just going to get cracking straight into it. So we're going to go over GraphScene again, just in a lot more detail, a lot more faster pace, and trying to find our own stuff within GraphScene. So we want to import our stuff from Manum. Let me make that a little bit bigger. Alright, so get your stuff from Manum, and this is what I want to do. So here is a little graph that I've got prepared. So I want to graph this within GraphScene. I want to put some dot there. I want to label it. Okay, this is just a super quick warm up to get us firing on how to use GraphScene again. So I want to put a dot there. I want to have this derivative function there. So I want to make a quick use of that. I want to have a slope occurring here. And what I also want is I want to have at this point at x equals 1 there, I want to have a horizontal line. Okay, so we haven't actually looked at using horizontal line because it's not predefined within GraphScene, but we're going to do it. So what I'm going to do is I'm just going to call this, I don't know, graphing. Oh no, I don't. Class. Graphing. GraphScene. And then we want to construct it. And pretty much what I'm going to do is I've got some of this prepared, so I'm just going to, no, where is it? Not there. That's an activity. Here. So I'm just going to pinch this right here. I'm going to slap it in. Alright, where I'm going my x mins, my x max and whatnot, just to match this here. So I want x min at -3, x max at 5, y min, y max, blah, blah, blah. Slap it all in there, and I want to set up the axis. Now I want to call my function, okay? So I'm going to just go graph equals self get graph. And I want to call that function, so I need to use a lambda function for x, and, oh, not that, into my OneNote. So this is 0.1 times x minus 3, x minus 1, x plus 1. So 0.1 times x minus 1 times x minus 3 times x plus 1. Yep. Color, I'm going to make it yellow. X minimum at -3. And x maximum at 5. So that's what I want to do, and I want to give this a graph label. So I go graph underscore label, just naming it. You can name it whatever you want, and then self.get graph label. And I want it to label this graph that I've just made, and I want the label to say, so label equals, and I want it to say something like f of x is equal to 0.1 outside of x minus 1, x minus 3, x plus 1, because that is my function, and I want it to go up, so I'm going to go direction equals up. Now this is something I'm calling within GraphScene, so again, you can just right click it, go to definition if you want to have a look at it in more detail, okay, but that's what Grant has defined. I'm just going to scale it down a little bit too, so scale equals 0.4. And I want to put a dot somewhere, so I'm going to go dot equals dot. And I'm going to move it to some point, where was it? -1, 0, I believe. Yep, -1, 0 on my function. So I'm going to self coords to point, because that's what I need to do to put it on the graph. -1, 0. And I'm going to leave that as it is. Now I'm going to get my derivative function. So I'm going to go deriv is equal, and Grant has got a self get derivative function, and we can check that out. So we'll go to that definition. We'll wait for it to pop up. No, it doesn't want to do it. Your computer's doing too much, mate. All right, well, pretty much what that get derivative graph does is you consider the graph that you're going to take the derivative for, and you just say take the derivative of that graph and give it a color, and I'm going to give it the color blue. So it's just going to graph the derivative function from -3 to 5, because that is what I've got here. So it's just the derivative of that on the graph, and I'm going to give this a label. Okay, so deriv underscore label is equal to. Now, Grant hasn't got a self.get derivative label, so we'll just make it ourselves with math text. I'm just going to f prime, the f prime of x, and I'm going to put it next to my derivative function up right with a small buff. Alright, so I've got that label there, and I also want to put on a slope. What I want to put on my slope at x equals -1 on my function. So I'm going to slope is equal to self.get secant slope group. Okay, so is this, are we going to be able to, come on, just open up. I think my computer is just doing way too much right now for it to open up. But you can go to the definition, it is within GraphScene. That's really annoying. I'm going to close some of this. It's getting on my nerves. I'm going to close that. Whatever. So I call an x point, so say x equals -1. I'm going to call on the graph. So I want to get my secant slope on my graph rather than my derivative graph, because that's what I'm trying to illustrate. And I'm going to say dx is equal to 0.1. Okay, so just making it a small distance between the two dots for the secant line, which makes it look like a tangent line. And I'm also going to, okay, so I'll leave that at that. And now I want to create this horizontal line from here to there. And so we don't have anything like that within within GraphScene. So I'm going to have to make it myself. So I'm going to h line is equal to, now I want this to be a dashed line. So I'm going to get dashed line. Now I have to have a think about where is this line starting and where is this line ending. So if I have a look back here, I see that it starts on the derivative function at the x point there. So it starts at x equals -1 and then f of -1. Okay, that's where that line's going to go, and it's going to finish up there, which is x being 0, y being f of 1. Sorry, f of -1. F of -1. So I need to find those as my starts and endpoints. So I've got self, and this is where it's going to start, self coords to point, because I want it to be on the graph. And what was it again? It was a -1, -1, and then I want f of -1 on the derivative graph. So I go deriv dot underlying function, underlying function, and this is of the point -1. Alright, so what I'm telling that to do is I'm saying go and start at the point when x is -1, take the y value of the derivative and put it there. So it'll be a dot there, and I want it to end at, can this bugger off now? It's doing nothing but pull up the definition. And I want it to end at self coords to point. So I want it to end at when x is 0, y is, and this is on the derivative, so underlying function of -1. That's where I want it to end. So this is going to call a dashed line that goes from, if I go back to my OneNote, here to there. Here to there. And we're going to start calling this stuff. I want this to be stroke width. Wait, I need to include a bracket there. Hang on, I need to include a bracket there. And I want this to have a stroke width equal to 5, and I want it to be orange. So stroke color is equal to orange. Okay, now I'm going to start playing this stuff. So stealth play, and I might just show creation of a whole bunch of stuff at once. So vector group of, I'm going to do graph, label, deriv, label, and I could make this look better by making a lag start, but I really can't be asked. And slope, and then we're going to wait, and then we're going to go self play, show creation of the horizontal line. And then we're going to wait, and we're going to see what that looks like there. And what I call this graphing. Okay, so I've accidentally put in an extra comma somewhere. Where is it? We're in my slope thank you for that error. And let's try to rerun that. Okay. Ah, okay, so you don't put the x equals -1, you just put -1. What is going on? Oh, it's not get derivative function. This is if I could ever load the definition within this. It's called get derivative graph, not derivative function. My bad. Should work now. Let me increase the bit rate a little bit. Let's go to 1500. Hopefully it doesn't shit itself. Alright, so have a look at that. Okay, so this is what we've got. We've got so we showed everything created, could probably move that up a bit. And then we've got a horizontal line that goes exactly where we want it to. That's nice. Now I could reposition some of this stuff, but I'm not going to because I want to get on with another animation. So that was just a little bit of a warm-up. I want to make something like this. Alright, so what I'm going to do is I'm going to call these two functions. I'm going to call these two, and really this is what I want to do. Okay, so I'm not going to inherit specifically, I'm going to inherit from GraphScene to get the axis and my graphs, but let's say you want to do something a little bit different to how Grant has defined it. So maybe you want to have a horizontal line with maybe some nicer looking trackers. Okay, so let's say I wanna create some function that hits this dot here. Okay, and then let's say it's a vertical line that goes down there, and I want to have some kind of a triangle tracker there with the text X under there. And what I also want to do at the same time is, because this is my function f of x, and I'm trying to illustrate some derivatives here, f prime of x, I might just put the slope at that point there. And what I also want to do is I also want to have a dot come there, a dashed line go all the way along here, have another dot. Actually, no, I don't want that next dot there. That's kind of annoying. I just want it on the coordinate. And I want to have my triangle tracker there, and I want that to say slope. Alright, so pretty much what I want to do is I want to create these two functions within GraphScene on the axis, and now I want to call a slope at x equals -3. We know how to do that. But now what I also want to do is I want to create this vertical line that hits the function and a horizontal line that hits the derivative function, where I can sort of see that at those same x points, I'm going to have a slope equal to whatever the y value is on the derivative function. And so let's say we want to do something like that. And this is really what we're going to have to do here. All right, let me pull up my coding studio. All right, so we're gonna get to that. All right, so we're gonna move on from this one. We're gonna create something new. It's a class, and this is winglec3, because I am somewhat winging this, but not really, because it's semi-planned. And we're gonna go def construct self. And now I want to create my axis. So I had my axis was self.xmin is equal to a -5. I don't need the comma there. Self.xmax was equal to 5. Don't need the comma. A self.ymin is equal to -5. Self.ymax is equal to 10. I want axis color to be white, because I'm a little bit particular with my axis color. I want the origin to be down a little bit, so self graph origin is equal to, let's say, down times 1.5, so down just a smidge. And I want to label some of these numbers, so self.x labeled numbers, and I want it to be listing from, we want it to go from -5 up to 6 in 5s. And I'm going to do a similar thing for y. So y, label numbers is equal to list, range it from -5 up to 11 in 5s. And I also want to change the width and length a little bit. So self.y-axis height. Okay, this is how you can change how long your axis is, but I'm just going to make both of mine 5. So x-axis width is equal to 5. So, and then I'm going to go self.setup axis animate equals false, because I don't really want to watch it. Now I need to create my two functions. So I'm going to go func for the original function is equal to self.getGraph lambda x such that it, and what is this function again? A third x cubed plus a half x squared minus 2x. Okay. A third times x cubed plus a half times x squared minus 2 times x, and I want that to vary from, what do I want it to vary from? A -4 up to 3. So -4 x max equals 3, and I want the color to be, what do I want the color to be? Red. Let's go red. Now I'm going to do a similar thing with derivative. So deriv is equal to self.getGraph. I want to call it on the same axis. And the derivative of this is equal to x squared plus x minus 2. And my x minimum is equal to -4. My x maximum is equal to 3. And I want this color to be green. So at the moment, what I've done is I've just created the axis and I've put my functions on. So my red one and my green one. I'm not going to bother labeling them because I know what the cubic and the quadratic looks like. But now I'm going to define this slope because that is going to be predefined. So slope is equal to self.getSecant slope group. And I want to hit the point -3 on the function func. On this one, I wanted to hit the cubic. And what I'm also going to do is I'm going to set a dx equal to 0.1, a secant line length equal to 4, so I want it to be a bit smaller, and secant line color. I want to change the color a little bit. I want it to be yellow. I don't know if that's the default color. So I've got my slope. Now what I need to do is, well, I want this stuff here. Wait, what happened there? There it is there. Okay. So I want this stuff here. Now I'm going to create a kind of like my own function. So if we want to do this, I go def get vertical line group. And within it, I'm going to take an X point and I'm going to take a graph. So now I'm not going to rely on Grant's stuff. I'm going to make my own stuff. And what I'm going to do is I'm going to create some sort of a group which contains a line that hits the axis that's vertical. There's going to be some triangle there. There's going to be a coordinate dot and there's going to be some text there for X. So let's try and do that. So there's going to be a result and it's going to contain a lot of stuff. So I'm just going to create a vector group for the result so that I can eventually return the result. But within this result, there's going to be a line. And that's equal to line, which self-coords to point. If we have a little think about where this line is going to start and where it's going to finish, it starts at, so that's going to be your point X up to the graph underlying function. So it goes from X to graph dot underlying function of X. So just to explain here, our line's going to start at the point X, comma, whatever graph you put in, and this is why I've wanted to create another thing here for graph, because if I want to hit it on the derivative or the function, I can pick either one, okay, by going graph equals whatever. But that's going to be one point there, and then I'm going to create my endpoint, coords to point, and I want it to end on, and then I want it to end on the point X 0. So it's going to go X, comma, 0. Stroke. I want to change the stroke width a little bit. Let's make it thick, 7, and let's make it what color do I want to make this? What did I have before? Orange. Orange. All right, I'm also going to add a coordinate. So coord is equal to dot. And I'm going to move that to the coordinate, which is self coords to point. And that's going to be x, comma, graph, x, comma, graph, underlying function, x. I'm also going to create a little tracker, so triangle is equal to, and this might be new, but this is just a mobject. Okay, it's a regular polygon, n is equal to 3. I'm going to scale it right down because mobjects are really big, so I'm just going to scale it to 0.1. I'm going to put it next to my line with no buff. So what I'm doing here is I'm creating a line like I want to. I've created a coordinate, and now I've created this triangle directly underneath it. The last thing I want to do here is to add everything is create my little variable. So variable is equal to math text, which is just x, and I want to position it next to my triangle down and maybe a little bit of a buff. So buff equals 0.1. So I've got a line, a coordinate, a triangle thing, and a variable. And so what I'm going to do is I'm going to go result add line coord variable. So I'm saying in this vector group of results, add all this shit, right? And then return all that shit. So when you go to play it out, what you're going to have is, actually, let's do it right now. So let me zoom out a little bit here. So I'm going to go self play show creation of my function, show creation of my derivative, show creation of my slope. Now, before I actually need to come up with something, so I'm going to say h line is equal to, and I'm just going to call this function that I've made, so get vertical line group, and I want the point at x equals -3, because that's what I've planned to hit at x equals -3 there, and I want it to hit the graph func. So I want it to hit this function here. I want the graph, I want it to hit the function. All right, so I'm going to create that stuff, and now I'm going to call, so self play show creation of the h line, and then we're going to wait. And now we're going to see if this actually works. So we're going to manim, run our animation. What did I call this one? Oh yeah, wing lec 3. Right, so that's exactly as we expected. We called our functions there, and what I've done here is I've created everything that I've wanted. So I've got my vertical line, a coordinate, a little triangle tracker there, and an x point, and my slope, right? So I can do that. Now, this is just best practice that I like to do. Whenever I make a function, I just close it off there because I don't want to have too much clutter on the screen. I'm going to do a similar thing here for this with this horizontal line. So maybe I want to make my own def get horizontal line group. So if you just want to make your own stuff to call within GraphScene, this is what we can do, right? Which is, if you want to customize your own animations, it's something that you definitely want to do. So same drill, right? I want there to be a result. So I'm going to say result is equal to vector group of a whole bunch of stuff. The stuff I want in there, I want a line, and this time I want it to be a dashed line. And I want it to start from the point x and then underlying function of that one there. So I'm going to go self coords to point, and we'll hit x dot graph underlying function of x, and then I then want it to end at, even though I'll have a look so I can see, I want it to end at the point when x is equal to 0, y is still that same value there. So I want it to end at 0 graph underlying function of that same x point. Okay, and within it, again, I'm putting in an X point and a graph, which is where I'm going to hit it at. Okay, and I want to change my stroke width. I'm going to make this one extra juicy, 15, and I'm going to make the color equal to blue. Again, I'm going to have a coordinate. I'm actually just going to copy. Oh, no, I'm not. No. I might just put a dot there. I might actually leave out the triangle stuff for this one, just because we already saw how it worked. But dot, and I'm going to go move to a self dot coords to point, and I want it to hit the graph. So at x comma graph underlying function of x. Actually, no, I am going to make my try. So I'm going to try equals regular polygon, and I want n equals 3, so I want it to be a triangle, like 3 sides. I'm going to scale it right down, 0.1. However, I don't want the triangle to look like that. I want the triangle to be, if you can imagine, you're rotating it 90 degrees. So I'm going to rotate. So I'm going to go dot rotate by pi on 2. Pi on 2. Let me just double check that. Yeah, pi on 2, because you can rotate around that way. And I'm then going to reposition it next to the line. Put it right of the line, because I want it to go over here. I don't want it to just be randomly on the screen. I want it to be right there. And I want there to be no buff, so I want it to be right next to it. And then I'm going to add a little bit of text, which is text of slope. And then results, add all this stuff. So line, dot, try, text, return, result. So I'm saying result is some vector group of stuff, create the stuff, put the stuff in the result, return the result. So it's going to return everything that I have made. And then I'm going to go, oh, this should be vertical line, V line, not H line, because that is a vertical line, not a horizontal line. Now I'm going to go H line, so I want the horizontal line, so get horizontal line group, but this is the one I've created. And I want it to hit X at -3. I want the graph to be the derivative. And then I'm going to show the creation of that. And so it should return a nice, thick, juicy line. This is my horizontal. There's my vertical. Okay, problem. Slope in the middle of the screen and way too big for my liking. So I forgot to go put this next to the triangle to the right of it, put a small buff, and I'm also going to scale it down because it was annoyingly big. So maybe like scale it to 0.7 or something like that. And let's see, just a small adjustment to it. Just a small adjustment. All right, so we see it creates the stuff. I'm a lot happy with that. Now, that's pretty much it. So from this point, like we've looked at creating some objects, using GraphScene, getting a little bit more complex within GraphScene, and creating our own functions that we can use within GraphScene. So from this point, we want to practice this a little bit, but then over the coming lectures, we're going to see movement within these graphs by using value trackers and updaters. So from here, we're pretty much just going to practice. So let me put in the first activity in a couple of spots. I'm going to put it in the Discord. And I'm just going to hang around, and if you guys have got some questions, just let me know. Alright, so this is the first one. So I want you to create the graph, configure your axis accordingly. At the point x equals 1, create a secant line, a secant slope. Between the points x equals -5 and x equals 2, call Riemann rectangles with a width of 1 unit. We probably should be able to remember how to do that from last time. It's just self dot get Riemann rectangles. Give the graph a title, position the title above the axis, so that's using it, next to stuff. And then bonus points, I actually did cover it explicitly because I changed up a little bit. Create a horizontal line at the graph x equals 3 to the y-axis. Once you've done that, pop it in the chat. Pop it in the Discord, should say. And I might just relax for a little bit and let you guys ask any questions or do the thing. How many didn't drop any frames? I could probably go this up a bit actually. Yeah, we'll see how that goes. Alright, so I'm going to put on some appropriate learning music and a fan because it's fucking hot. And that's right, very good. So where is this one? It should be Manim Lec 3. Alright, so it should look like this. Sweet. So it should look something like that. Alright, that's cool, Raldo. I mean, you can try the stuff later if you want. I mean, the code's there to double check, but I mean, I'm probably just gonna talk through it. I'm probably like this one's a little bit of a shorter one. Yeah, it's just shorter because I really want to just get GraphScene down because everything onwards is just value tracking within GraphScene. So if you're comfortable with it, you're comfortable with it, and that's good. Not sure good to do with today's lesson, but how best to create a surface that says on which I can draw boxes. I don't really know what you mean. Dave Hid H. Maybe if you like drew a picture of it or something and took a photo. I'm not 100% sure on what you mean. But if it's got to do with like creating tables within Manim, so like it's like creating something like, I don't know, let's go to the side here. Creating something like if you want to make a box with like a whole bunch of stuff to put in it, and you want to put stuff in here, then put stuff in there and there and there and there and there and so on. I don't actually know a good way to do it. That's my honest answer. Hey, thanks for the comment, Dietmar. I mean, I don't really mind that not too many people are watching. You know, it's just a little way for me to give back to people who are struggling and actually want to learn. Because, yeah, like I started learning, I didn't know any Python. I literally never looked at any coding in my entire life. Like 6 months ago, and so I wanted to learn it so I could explain it better to the kids I was teaching, and I was just getting really like pissed off and frustrated with like trying to like make it work because there was a massive lack of documentation, and so yeah, I just wanted to give back a little bit. So I mean, you know, like if 10 people watch, I don't mind. That's, you know, that's 10 more people who are, you know, who are learning a thing or two about Manum, because it's quite complicated. And even if people want to watch it at a later date, I don't mind. Or even just look at the code, and if they can look at the code and go, oh cool, okay, that's how it works, then great. Like even that's good. But you know, it's nice to know that you appreciate what I'm doing. That's always lovely. I'm gonna get rid of this stuff here. Yeah, and I'm actually gonna drop the second activity because it's harder. What do you have to do? Create a number plane. Oh yeah, side by side number planes. Ah, cool. Okay, that one's actually a little bit harder. And I probably should. Have I not run the code yet? I haven't. Does it even work? Did I even do it? Yeah, I did. Yeah, I did. Okay, let's see if that works. What did I call this one? Lec 3 activity 2 PM, because I don't want it to render forever. I dropped any frames? I haven't. I should really just up it a little bit more. Now that I'm testing and waiting. Yeah, that's nicer. Okay. Yeah, so hopefully that... Let's see how that rolls, but... Yes. Okay. What's this one again? That's right. For example, I draw 4 rectangles at a specific location. I can do this in Scene, but is it just a matter of managing scale? Or is there a better way? David. Okay, cool. How the fuck? Oh, that's a good question, man. I'd have to have a good think about it. The way that I'd sort of approach this one, David, is so for example, four rectangles at specific locations. So you want this, yeah, so you're saying you've got a grid 256 by 144. Look, if I was doing this, I would create a number plane that takes up the whole screen from, and it goes up 144 units, it goes across 256 units, and I would just be creating stuff as like vertexes on there. So my screen, and I'd use like plane dot coords to point and put the vertexes there. That would be how I'd do something like that in Manim. Manim's really not the best program to use. I'm not sure what you're trying to do with it, but it seems like a lot of effort for something you'd probably do somewhere else. But yeah, you probably could do it with number plane. Let's have a look. Wait, that's good as. Hang on. Yes, you got that. Nah, that's nice. Yeah, good. Good. Froth that, that's mad. Did that finish rendering? It did. The application is effectively animated Kusarin rods, if that makes sense. What the hell is a Q? What is this? I've literally never seen these in my life. I don't want to buy them. I just want to look at them. Oh, okay, actually no, I think I know the ones you're talking about. Just seems painful to do in Manum. I have no idea if there's another program that would do it, but you could, and I guess to animate them, like if you wanted to add trackers to them, that's what we're doing in the next lesson. Like if you were to define them on a number plane and you want them to move around, you could do something like that, yeah. Have I dropped any frames? 0. Okay. Well, that's promising. Yeah, I'm trying to think of like a programmatic way to do it, David, because a lot of the stuff that you use in Manum, you want it to be programmatic so you can do everything efficiently and to save time, and something that you wouldn't be able to do on like another program. Which is, I mean, I mainly do calculus, linear algebra, a lot of calculus. What else do I do? Oh, like probability, like just like distribution simulators and random sampling simulators, stuff like that. And like a little bit of like trigonometry stuff, because you can programmatically move it around once you get your updaters down. Like, I know I'd have to like sit down and you'd have to show me what you mean, because I feel like we might be on a different wavelength here. I suspect we are, actually. But if anybody's got questions, let me know. Otherwise, I'm gonna skedaddle in about a minute, because I'm fanging. And he dropped. No dropped rates. Alright, well that's really cool. I'm gonna close that off. I'm gonna close me OneNote too. Ah, yeah, nice, yeah. Yeah, always side exploring. Always side exploring. There's I don't know his name, I think it's Alex. His YouTube name is Theorem of Beethoven, I think that's how you say it. He's got some really cool, like, creative stuff that he's made with Manum. That's just, like, some of it's not even math related. It's so cool. So, yeah. Like, although it can be painful, creativity is definitely worth exploring. So that's sweet. And I mean, I teach psychology as well.